In this video, we are going to talk about and simplify rational expressions. So, the property of equivalent fractions. You learned this a long time ago. If you have A times C over B times C, then that reduces to A over B because the C's cancel as long as B is not equal to 0 and C is not equal to 0. A times C over B times C. Okay, this is a factor, C is a factor, C is a factor, A is a factor, and B is a factor. So when you're doing all of this multiplying, those are called factors. Multiplying factors. Unlike A plus B, let's make it the same thing, A plus C over B plus C. These are addends. So these are things that we're adding together. Now you can cancel out common factors. You cannot cancel out common addends. Okay, so you cannot cancel out common addends. Now what we're going to do is we're going to have two steps. I'm going to put these in purple here. Step 1 and step 2. Step 1, you're going to factor the numerator and the denominator completely. So now this time the numerator is very much involved. We'll factor the numerator completely and the denominator completely. And then we will cancel out any common factors in the numerator and denominator. So any factor that is shared to both the numerator and the denominator will be able to cancel out. And I'll show you on this first example. Number 10 says 8t minus 16 over t squared minus 4. First step is to factor the numerator and the denominator. 8t minus 16, we can factor an 8 out, leaving us t minus 2 in parentheses. Now I have two factors there. I have 8 as a factor, and I have t minus 2 as a factor. Then in the denominator, t squared minus 4 becomes t plus 2, t minus 2. And I have two more factors there, t plus 2 and t minus 2. So I have two factors in the numerator, two factors in the denominator. Do I have any common factors in the numerator and the denominator? Well, I sure do. T minus 2 is in the numerator and it's in the denominator. Now before I do that, I'm going to need to say that t cannot equal negative 2 or positive 2. T cannot equal negative 2 or positive 2. Now when they cancel out, I'm going to have 8 over t plus 2. 8 over t plus 2. And as that's going to work as long as t is not equal to negative 2 or positive 2. Let's try another one. We have a squared minus 16 over a squared minus 8a plus 16. I'm going to factor the numerator to be a plus 4, a minus 4. And in the denominator, a squared minus 8a plus 16 is a minus 4 times a minus 4. I'm going to make myself a note. I'm looking at the denominator, and a cannot equal 4. So I'm looking at this denominator right here, and a cannot equal 4. Now I'm going to cancel out common factors in the numerator and the denominator. And that's going to leave us a plus 4 over a minus 4. Now notice how I put the a plus 4 and the a minus 4 in parentheses. That's because I cannot cancel out the a's because those are addends. I can't cancel out the 4 because those are addends. So a plus 4 all goes together, a minus 4 all goes together, and those are not common factors, so they both remain. And this all comes down to factoring. Let's try and factor number 12. And at any time, I encourage you to press pause and see if you can factor before I show you the factors. That will give you practice factoring, and it'll give you confidence that you can do these problems on your own. Number 12, x squared plus 9x plus 8 over x squared minus 3x minus 4. I'm going to factor the numerator, which will factor to be x plus 1 and x plus 8. And then I'm going to factor the denominator, which is going to be x plus 1 and x minus 4. Off to the side over here, I'm going to say that x cannot equal, now it can't equal negative 1 and it can't equal positive 4. Then I'm going to look at the common factors. X plus 1 is in the numerator, x plus 1 is in the denominator. So I have x plus 8 over x minus 4. X plus 8 is a factor, x minus 4 is a factor. Those are not the same, so they don't cancel. Okay, you try number 13 and then come back when you're ready to reveal the answer. Okay, on number 13, it factors to be t minus 9, t plus 1, and the denominator is t plus 1, t plus 4. Now, t cannot equal negative 1, nor can it equal negative 4. The t plus 1's cancel, and we're left with t minus 9 in the numerator over t plus 4 in the denominator. I'm going to put those in parentheses just to remind myself that the t's cannot cancel out. Now what I'd like you to do is I'd like you to turn your paper over. I want to talk about an idea here. If I have a plus b over a plus b, those are common factors, and that would be 1. If I have a plus b over b plus a, that's the same thing as a plus b over a plus b, and that's equal to 1. But once I start using subtraction, and I have a minus b over a minus b, that's the same thing, but a minus b over b minus a is not equal to 1. A minus b over b minus a, that's the same thing as a minus b over the opposite of a minus b. Now I want to go slow. A minus b is the same as a minus b. Put parentheses around it. Right here, if I were to take a negative to the outside, b would become negative, which is right here. And then if I take this negative out, a would become positive, which is right here. So when I factor out that negative, I get the opposite of a minus b. Therefore, the a minus b over a minus b cancels, and I have this negative right here, so I'll have negative 1. So the rule is that if I have the same exact values being subtracted in the opposite order from the numerator than they are in the denominator, that's going to equal negative 1. that's going to equal negative 1. So when I see a minus b over b minus a, that equals negative 1. So if I see x minus 7 over 7 minus x, that's equal to negative 1. If I see 5 minus 2 over 2 minus 5, that's equal to negative 1. If I see 3a minus 8 over 8 minus 3a, that's equal to negative 1. So now let's come back here and let's take a look at what we've got for number 14. In the numerator, we've got 2t minus 1, and in the denominator, I've got 1 minus 4t squared. Well, 1 minus 4t squared is a difference of two squares. 1 is a square of 1, and 4t squared is a square of 2t. So this is going to factor 2t minus 1 in the numerator, and then in the denominator, I'll have 1 plus 2t and 1 minus 2t. Well, 2t minus 1 is the reverse position of 1 minus 2t. So that's going to simplify to be negative 1. So I will have a negative 1 in the numerator and 1 plus 2t in the denominator. Okay, let's try number 15. Number 15, the numerator factors, the denominator factors. See if you can do this problem, and then come back and press play and check your answer. Okay, 25 is a square of 5, and p squared is a square of p. So the numerator is going to be 5 plus p, 5 minus p. And the denominator is going to be p minus 5 over p minus 5. Now I see it again. 5 minus p is the exact opposite of p minus 5. So when I cancel those out, I'm going to replace that with a negative 1. So in the numerator, I've got negative 1 times 5 plus p, and in the denominator, I've got p minus 5. Now, lots of different ways that I can write this. I can say, well, let's distribute that negative 1, and I'd have negative 5 minus p over p minus 5. That's one way to write it. But if I look at this, I see 1, 2, 3, 4 terms. And out of those 4 terms, 3 of the 4 are negative. That's a lot of negatives. So what I can do instead is I can take this negative 1 and I can move it to the denominator. And I can say that 5 plus p is in the numerator, and then I have the opposite of p minus 5 in the denominator. That's going to make p negative and 5 positive. So I'll have 5 plus p over. P is going to be negative. P will become negative, and negative 5 becomes positive. So I'm going to put the positive 5 first, minus p. Now, as much as you might want to cancel out those 5s, the factor in the numerator is 5 plus p, and the one in the denominator is 5 minus p. Now, these are not the exact opposites of one another. This is a sum, and this is a difference. In the problems that we canceled out that became negative 1, we had a difference over a difference. We had a difference over a difference. This is not a difference over a difference. So that's going to be our final answer. 5 plus p over 5 minus p. And now we're just going to continue to practice. We'll practice finding our domain of our rational functions, and we will practice simplifying those rational expressions, canceling out common factors.